This is an asteroid headed for Earth. And this is a rocket ready to crash into it. In the early morning of June 30th, 1908, an asteroid detonated in midair, about 5 to 10 kilometers above ground. The blast unleashed the energy of 10 to 15 megatons of TNT, 1,000 times more powerful than the Hiroshima nuclear bomb. This was the Tunguska event. Over 2,000 square kilometers of taiga forest were flattened, making it the largest asteroid impact ever recorded. A typical meteor impact speed is 17 to 25 kilometers per second, up to 110 times faster than a commercial airliner. An asteroid with a diameter of 10 to 20 meters can cause window-breaking airbursts, resulting in localized damage and injuries. Those with a diameter of 50 to 100 meters can release the force of a few hundred nuclear bombs. Even larger ones could devastate a country or even cause global climate disruption. For decades, engineers have searched for ways to defend against asteroids. In 1967, a group of MIT students led by Professor Paul Sandorf developed Project Icarus, a project to defend against asteroid 1566 Icarus. This asteroid was imagined to be on a collision course with Earth, a potential threat coming from space. Their plan was to use 6 Saturn V rockets carrying 100 megaton nuclear warheads to deflect or detonate the asteroid. But due to massive technical challenges, the project didn't go beyond the proposal stage. In the 2010s, NASA started working on the Double Asteroid Redirection Test, or DART. Their objective was to demonstrate a method of planetary defense by changing an asteroid's orbit by a kinetic impactor, essentially crashing something into it to nudge its path. The target was the binary asteroid system Didymos. The smaller body, Dimorphos, is a moonlet about 160 meters across, and the larger body, Didymos, is about 780 meters across. Neither Didymos nor Dimorphos posed any risk to Earth, and the system was selected for safety and observability. The DART kinetic impactor was launched on November 24, 2021, aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base, California. It had a mass of around 570 kilograms and had a main instrument called Draco to visually track and lock onto Dimorphos. After about 10 months of cruise through space, DART intentionally collided with Dimorphos at a speed of about 24,000 kilometers per hour. Dimorphos's orbit time around Didymos changed from 11 hours 55 minutes to 11 hours 23 minutes, shortened by 32 minutes, rendering the mission successful. There are some other theoretically possible ways to stop an asteroid from hitting Earth. For example, the gravity tractor, primarily focused on gradually changing an asteroid's trajectory using the gravitational pull of a spacecraft. A spacecraft is positioned a few thousand kilometers from the asteroid. The spacecraft's mass, although small in comparison to the asteroid, exerts a gravitational force on the asteroid. The force exerted would be in the range of micronewtons to millinewtons. Because this force is so small, the spacecraft would need to be in position for a few years to shift the orbit of a large asteroid by a few hundred meters. Another way, sounding like something from a sci-fi movie, is laser ablation. A laser is blasted from a spacecraft, heating up and vaporizing the surface of an asteroid. This causes gases to be ejected, creating a thrust which pushes the asteroid off course. This method requires extremely powerful lasers, which might not be feasible with current technology. Power levels from tens of megawatts to gigawatts are required, up to billions of times more powerful than a laser pointer. These are some ways to stop an asteroid from hitting Earth. Although rare, there are some asteroids close to Earth, and there have been some near misses. 2004 MN4, or Apophis, an asteroid about 370 meters in diameter, gained significant attention when it was initially thought to have a chance of colliding with Earth in 2029. However, more observations have shown that the chance of impact is nearly zero. 1999 BQ36, or Bennu, has a 1 in 2700 chance of impacting Earth sometime between 2175 and 2199. 2002 NT7, about 1 kilometer in diameter, had a small probability of impacting Earth in 2019, but has been ruled out by later studies as a non-threat. Asteroid impacts are rare, but the stakes are high, from Project Icarus to DART, and ideas like gravity tractors and lasers, we are developing ways to defend our planet. With early detection and continued innovation, we can prepare for the threats from space before they reach us.